Exercise 14. Compound function solution. The good news is that in order to create the correct convoluted or compounded distribution, we do not need to create a one-by-one case for each model of type frequency times impact as we did on the previous exercise. At-risk does have a very powerful function that does all of it, the convolution automatically. It is called the RISKCOMPOUND function. It is used to return the sum of a random number of independent random values from a specified distribution. Specifically, it returns the sum of a number of samples from the second distribution, where the number of samples drawn from it is given by the value sampled from the first distribution. Typically, the first distribution is called the frequency distribution, or Poisson, and the second distribution is the severity distribution. RISKCOMPOUND is evaluated each iteration of a simulation. The first argument's value is calculated using a sample from the frequency distribution. Then, this number of samples are drawn from the impact distribution and summed. The sum is the return value for the RISKCOMPOUND function. In other words, use the compound distribution to automatically multiply frequency of annual snowstorms with a Poisson at 6.5 per year times its severity or impact with a PERT for a duration of a snowstorm as in exercise 12. Doing this compound function is exactly the same as building the previous exercise, but it is done automatically. On blank cell B132, click on the Define Distribution icon to select a compound distribution out of a palette's Special tab. Double-click on the compound distribution to retrieve its respective window. Observe on the top Excel formula section that a compound distribution has two different components, a frequency part and a severity part. By clicking on the risk Poisson segment of the formula, its frequency section, the following chart appears. Also, the parameter section becomes ready to accept lambda, the only required parameter of a Poisson. By clicking on the risk log norm segment of the formula, the severity part, the following chart appears. Also, the parameter section becomes ready to accept the two required parameters of the severity function, in this case the suggested log normal. We will not be using the log normal distribution though. The severity will be modeled with a PERT distribution. Click on the risk Poisson section of the compound function, and by clicking on the parameter standard line, click on Specify Excel References option, make a reference to cell B100 that contains the average number of snowstorms per year. This is the lambda or average required by the Poisson distribution. After clicking on the icon of the upper right-hand corner of this small window, At-Risk will take you back to the Poisson with the correct lambda parameter. Now, click on the severity section of the formula, the log normal, and see how At-Risk displays now the standard log normal distribution to model severity. We will change this to a PERT. On the function section, scroll down to change from the default log norm to a PERT distribution. By clicking on the parameter standard line icon, click on the Specify Cell References option, the following window will appear. Insert referenced values for the minimum B103, the most likely B104, and the maximum B105. The respective use parameters by the PERT by clicking the Control key simultaneously. Click on the upper right-hand corner of this small window to return to the updated PERT severity subdistribution of the compound. You can now close the creation of this compound function with its respective subcomponents for frequency and severity. This formula should look like this: equals RISKCOMPOUND, open parenthesis, risk Poisson, open parenthesis, B100, close parenthesis, comma, risk PERT, open parenthesis, B103, comma, B104, comma, B105, close two parentheses. Declare this cell as an output using the Add Output icon on @risk ribbon. It should contain the following function once it has been declared as an output by naming it compound function. Equals risk output, open parenthesis, double quotes compound, double quotes, close parenthesis, plus risk compound, open parenthesis, risk Poisson, open parenthesis, B100, close parenthesis, comma, risk PERT, open parenthesis, B103, comma, B104, comma, B105, close to parenthesis. Once again, run a simulation with 10,000 iterations. Our intention here is to compare the previously created functions, exercises 12 and 13, with this compound one. If you have already done the two previous exercises, then the results summary window should now contain an overlaid chart, such as the one shown in the next figure. On top of this chart, once the simulation has stopped, we will overlay now the compounded distribution as a third one in order to be able to compare the three simulated outputs. When the simulation finishes, go back to the results summary option on the Explore icon and drag the previously created one with the two outputs overlaid. From the summary window, drag output the named compound function of cell B132. The three overlaid charts should look like the following. You will now be able to observe three probability bars for each one of the outputs on the chart. Observe that the second and third overlaid curves are essentially identical. Their numerical differences stem out of the natural randoms of the Monte Carlo simulation process itself. In other words, with enough iterations, both curves will converge to the same statistics and shape.